Hello and welcome. In this video, we'll be solving question 6. Question 6 is inverses, functions and inverses grade 12. So this one, it's the inverse of a parabola. So, okay, let's get straight into it. So question 6. The graph of f of x, right? So the graph of f of x, we're given there that f of x here is equal to minus square root of 27x, right? And the domain of the graph was given to be restricted only for positive x values, right? And it's sketched there. So this is a graph. So this is not the parabola we know, but this is the inverse of the parabola, right? It's okay. So it means that that's the inverse of parabola is given as the original function there. So now let's go and look at what else is given. We're given the point again here that it's 3 and minus 9, right? It's there on the graph. That point we can clearly see there. It's of that graph of f, right? So the first question just went on straight and said use the graph to determine the values of x for which f of x. So we need values of x for which f of x is greater than or equal to minus 9. So the first thing we do is we think of this minus 9 as a y value. So it means that this is going to be y equals to minus 9. So we ask ourselves, where is this y minus 9? Is this just a random line, horizontal line here? But because fortunately here we have a coordinate, that from this coordinate we can see that this is 3 and this is minus 9. So it means that this vertical line we can specifically draw it passing through that, right? Passing through our coordinate, right? So this is y equal to minus 9, right? So we're looking for where the graph is above minus 9. Where is the graph above minus 9? So if you've been paying attention, you would have noticed that the graph is above minus 9 from this x value going to the left. Do you see that? Because going to the right, the graph is below. So this is below. So the graph is below the line. The y is equal to minus 9. The graph is below here, but then the graph is above at this point. Do you see that? So what are these x values? We're looking for those x values. So I can see that here it's from that specific x value there. You can see that this is from that specific x value 0 to that. So the graph it's above, in between 0 and 3. These are the point where the graph is above that, right? But how are we going to write it here? We would say that the x, we can see that the x is bounded between 0 and the y and the other value, which is 3. So we would include this because the graph exists at the point and because they're including that. Do you see that here they're including the value? So we would include the critical value there, and then we would also include 0. So be careful next time, because this was a parabola. A parabola does not have an asymptote at x equal to 0. It's a log function that has an asymptote at x equal to 0. So we would not necessarily include the 0 if it was an exponential graph, right? But on this one, if it was a log function, we were not going to include 0, right? Yeah, I know what you. I think you know what I'm talking about there, because you must have watched videos or tried to solve this question for an exponential, right? But for this kind of a question, this would be the response. So let's move on to the next one. 6.2. Write down the equation of the inverse, right? So they gave us f of x there. F of x is minus the root of 27x. They're looking for the inverse. So remember the steps on getting that. We must first interchange. So x would be this. And here we'd have 27. Y. And then let's do the interchanging. So this part here we interchange x and y. So let's make y the subject of the formula. We want to make y, right? The sub of the formula, subject of the formula. So how do we do that? We don't automatically involve logs, right? The logs were only there to get rid or to make y the subject of the formula if your unknown if your unknown variable was an exponent, right? So for this one, we just simply going to square both sides. So we'd square here because we want to get the y isolated. So squaring both sides will give us x squared here, and then this would get us 27y, right? Because you can punch at the calculator there, you'd see that would get a positive, that, and then the y value here. Remember the restriction here was x is greater than 0, right? So we're looking for the inverse of that function there. Can I erase here? Can I erase here? So we're looking for the inverse of that function. So it means that we'll divide both sides by 27. Remember, this is the part where we're making y the subject of the formula. So the y value here would have been x squared over 27. And then I think that's the y value there. So now, what is our a value here of this parabola? This is a parabola function, right? Remember, parabola function must be like this. So it means that this is y equal to 1 over 27 with x squared, right? So the a value for this one was simply 1 over 27. If we write that on its simplified form, right? I think to include the restrictions here, remember, let's take a look at the quadrant where our inverse was gonna be drawn on, right? So this is the line y is equal to x, and the inverse of this, if you put a mirror here, you would see that you would see a graph that looks more like that, which this graph is on the negative quadrant. Well, what is the domain and the range of this? What's drawn here? What is the domain? The domain is x is less than or equal to 0. What is the range of what's drawn there? Y is greater than or equal to 0. Whereas what is the domain of this one? The original would say x is greater than 0. It's given there. But what is its domain? What is its range? Its range is y is less than, because we're looking at the negative values here, right? We're looking at positive values and positive x values and negative y values. So I would say y is less than or equal to 0. Here I would say y is greater than because I'm looking at the positive y, but then when it comes to x is negative. So they said we must include all the restrictions here after looking at the inverse of that function. So what are those restrictions? Those restrictions are basically its domain and its range. So we can write that the domain, it's simply x less than or equal to 0, and the range, it's y greater than or equal to 0, right? So now let's move on to the next question. 6.3. So they were saying that sketch graph of the inverse. So because we have already sketched it there, right? I'm not going to necessarily sketch it again, right? But okay, if we sketch it again, it's just gonna look like the same thing, right? So it means that you can first sketch this one and then sketch the inverse of that, because it's easy to sketch the inverse of a function while you're looking at the function, which is simply a reflection about the y is equal to x line, right? So the graph was going to look more like that. And then they're saying that we must indicate just one point. So this is the graph of f, which you don't have to draw there. You can draw in pencil and then erase it after. But this is what we have to see. The inverse of that is what we want to see. The inverse of that, which is f of x. So what is this point here? The coordinates here, we can just interchange the coordinate pair we had here. It was 3 and minus 9. So it means that on the inverse, it will be 9 and minus 3. So remember that the inverse and the graph, they interchange everything. The x coordinates and the y coordinates would swap, right, for that. And then also the domain and the range would swap, as you can see here with the domain of this one and the range. If you pay attention to it, so the x here just swaps here and then we interchange, or you can simply interchange x and y for the information of the other one, right? So they just interchange everything. They just literally interchange everything. I think it's perfectly fine there with that, and I think you're having some ideas here on how to approach these kind of questions. So 6.4, describe the transformation for f from f to g. So we have f to g. How did we just move from f to g if g is that, right? But what is f? Remember, f of x, original function, is minus root 27 x, right? So all of a sudden we having a graph g and it looks like that. So let's just check there. So the type of a transformation here, it's most likely that it's a reflection, right? We don't know what type of reflection, right? So let's check if they substituted x with minus x. So f of x is minus root 27. Do you think we substituted x with minus x? Do you think they did that? Okay, let's go and test that. We would get square root of negative 27, which we can't get the negative out here, so this is not our g function, right? So it means that that's not a type of transformation that was performed here. If that was the type of transformation that was done there, we would be seeing the same graph of g here, right, after we've performed such transformation. So that's not the transformation that was performed there. So now let's go and take the g of x function and test for a different transformation, or a different reflection rather. So we're going to have this 27 x, and then what if now we substitute y with minus y, just to see what's going to happen. Remember, f of x is just y, and then should we do that, we substitute y with minus y, it means that the y value was going to be multiplied by y by minus 1, right? So we substituted the y with minus 1. You can just simply write like this, right? So this is the original function and this is the transformed graph. Oh, sorry about that. Let me plug it. Okay, let's continue now. So we can see that they changed that graph, then we'll divide both sides by -1, -1. So we can see that the y value here looks exactly like the graph of g, right? But what did we do here? We swapped y with -y. So it means that this type of transformation that was performed here, it's the reflection about x-axis. So if they change y, we know that it's a reflection about the x-axis. So it means that for that question there, they simply transformed the graph of f by reflecting it about the x-axis, right? That's why we see the y value being the one changing there, right? So even though it was just a 1 mark question, but we spent a lot of time discussing this because I want you guys to get some ideas on how to actually solve these problems in exams. And I think I keep repeating one and the same thing on most of these videos, just for you to learn, and should you understand the stuff here while watching them, it'll be very easy to recall most of this stuff in the exams. So I think it's perfectly fine there with this video. And then thank you, and